Good afternoon. On behalf of the NASA Administrator, Senator Bill Nelson, I'm both honored and delighted to be here today to share with you some of the accomplishments that NASA has had in the aviation area. But I want to start by giving sincere thanks to Dr. Walter, or Professor Walter, as well as Leah Wickman and Marvin Minge for their attention to detail and for welcoming NASA here today. So like all good briefings, we're going to start with a video. NASA likes videos. All right, so that kind of got us warmed up. I could actually sit down now because that was pretty much my video, or was my speech, but wanted to first kind of orient you to NASA. I'm really excited to be able to talk to you a little bit about aviation. Most of the times when I talk, I end up talking about exploration systems and Artemis, but NASA in particular was founded just about 65 years ago. I don't know if I hit the wrong button here. I'll leave it here. And we're so really excited. And in America, 65 years means you can retire. So in that 65 years, what we're doing is we're taking a bead in the agency, and we're thinking about NASA in 2040 and what we're going to do to formulate and innovate for the future. NASA 2040 for us is important because that is when we do expect to be able to land on Mars. So that's why we chose that date. But we have about just under 20,000, about 18,000 employees. We have a budget of, at this time, about $22 billion. I think many of you know that our Congress is, I don't want to say dysfunctional, but we don't quite have a budget yet. But we are expecting or anticipating to get around $25 billion this year. And this is our new vision with respect to 2040. And NASA is transitioning in that we are not trying to do everything for everybody with respect to aviation and space exploration. We're intending to be leaders in institutional research, engineering, and technology, and to be able to leverage the commercial sector and industry in how we accomplish our mission. So we're organized into 5 mission areas at NASA, as well as 1 mission support area. We're going to talk about aeronautics research today, obviously. That's about 4 to 5% of the budget at NASA. I mentioned earlier that our research in aviation directly benefits today's air transportation system. We don't build aircraft. We don't even do prototypes. What we do is we do modest investment in what we consider innovative things that will be instituted or would be transitioned to commercial aviation. What we say about NASA Aeronautics is we only exist to augment industry capabilities and to partner with industry. Sometimes early investment is needed in areas that don't have an immediate payoff in order to transition those technologies into commercial industry. Exploration systems is about 30% of our budget. That's where our Artemis program, we have low Earth orbit as well as deep space that you're familiar with there. Won't spend a lot of time there. Space operations is also an area many are familiar with. That's where our International Space Station sits, as well as our commercial crew and commercial cargo that you see SpaceX kind of sending. I think we're on crew number 6 right now. And then also there we have a new procurement that we're getting ready to start about deorbiting the International Space Station in 2030. And then we are looking to put in place, we're doing some strategy development for an international joint venture for the next gen space station. In science, that's about another 30%. That's where we do all of our telescopes, satellite systems, research and development. We have a lot of work being done there in climate science as well as planetary defense. And then lastly, in the actual technical areas, we have space technology. Space technology is the area that we look at for technology insertion, not just incremental improvement, but we're also looking at game-changing technologies. And then finally, the unsexy part, the mission support. That's everything that it takes to run the agency, like your IT, procurement, where I sit, your financial operations, security, logistics, and the like. So this is where NASA is located. We're all around the United States. If you notice, we're not in the middle of the United States. We're kind of all around. But we're in some very strategic locations. We have our space flight centers. We have space centers. We have testing and launch facilities, as well as a shared service center located. We do have one FFRDC, as we call it, a federally funded research and development center, and that's the Jet Propulsion Laboratory, and that's in Pasadena, California. So let's talk about aviation for a second. How important is aviation to the United States? How important is aviation to society? It's vital. And in the United States, aviation is vital to the success and the operation of our economy. One of the things that we gave you a few stats up here with respect to the amount of cargo, about 24 million tons that we transport. 8.9 million flights are done by U.S. carriers worldwide. And the export of aerospace and defense and that particular sector is the only sector that consistency year over year actually has a positive trade balance, and we're very proud of that. So we're at 51.5 billion. Just before COVID, we're at just about 78 billion, but the 51.5 is over and above where we were in FY 2020, which was COVID, right? And that was 40.6, so that was our low, 40.6 billion. So we are just getting back to what we consider the pre-COVID era with respect to exports. We do have a little over 2 million jobs in the aerospace industry. This right here just gives you kind of a picture of the aerospace or the aeronautics budget at NASA. You can see we're on a positive trend line. So we're getting close to $1 billion. It's about, like I said, 4 to 5% of our budget that goes into, and this would all be procurement or dollars that are invested with industry here. This kind of tells you, it's a bit of an eye chart, but it's one of the charts we really do like to show because it shows that NASA has made decades of contributions in the world of aviation. We develop technology that's on board every single U.S. commercial aircraft and control tower and many of our international partners. You could see the computational fluid dynamics, lightning protection standards, airborne wind shear detection, air traffic management, even runway grooves we actually fielded and tested. We have something called NASA TRAN or NAS-TRAN, and so that's a huge NASA structural analysis area of science and testing that we do. And a lot of that work has led to some of the composite structures that we use every day in aviation. We also have a series of wind tunnel facilities that are used for aviation, as well as a lot of work that we've done on jet engine combustors. So the history, we like to say, let's fly. The history of NASA with respect to aeronautics is what we call the first A in aviation. It's very important to our space program, aviation, that heritage that started with the X-15 flight. That was the first manned or crewed flight in 1959 that moved at supersonic speed and set records that have still yet to be broken. Because we have aeronautics, most people think aeronautics and space. I know this is a very technical crowd, but obviously you understand that a spacecraft has to go through the Earth's atmosphere twice, once up and once down, and that is aeronautics at its very core. So the science of aerodynamics, thermodynamics, materials, and structures all play a role that started with the aviation and aeronautics at NASA. In fact, many may know, but this is an international audience, that NASA, it was NACA, it was actually an aviation or aeronautics organization or committee, and it was formulated in 1915, shortly after the Wright brothers did their work. But after that X-15, the hypersonic flight there, what we did was we turned and focused more on the space, which everybody knows from the Apollo program and all of that. And at that point, we changed the name from NACA to NASA. All right. So this is something I wanted to talk about with respect, I was actually on the other chart, but as far as innovation goes, why do we want to innovate now? I guess I should go back. So I don't lose everybody. We want to innovate now. We think this is exactly the right time because we do have a strong commercial marketplace that exists. We do have a flattening federal government in the United States aviation budget. We do have a global reach, as you know, I'm here in Germany, with respect to aeronautics, and impact with small investments can be made globally. We do know we have congested aviation lanes. We also know that there's an increased demand for air transportation. We all know that when we go to the terminals to get on an airplane, as well as a demand for supplies and logistics that's only done through air transportation. We're also focusing very heavily on the quality of manufacturing and safety of flight, so that is the why. Our aeronautical innovators at NASA are exploring technologies to do many of the things that have already been talked about here today. One, which is reducing aircraft fuel burn, reducing emissions and noise, and getting you gate to gate safely and on time. So at NASA, we hope to transform this aviation economic engine at all altitudes. So we have 4 examples of some of the things that we're doing, what we call 4 transformations that we're doing in aviation at NASA. What's really interesting about all of these transformations is in many cases we're no longer using contracting. I have to talk about contracting because I'm chief of procurement. We're not using those standard formulation contracts, what you would call the federal acquisition regulations. We're using other transaction agreements, in many cases what we call partnerships. So our contracts that aren't contracts are formulated much like a commercial agreement. In many cases, there's $0 agreements that we make with industry where we actually share data, we share facilities, we share knowledge. And we do that to demonstrate technologies. And as I mentioned before, sometimes it's not actually a prototype, it's an idea or something that could be implemented in an airframe for the future. So with that, we also do have some funded what we call funded agreements as well. NASA has a very unique authority with respect to the way we do other transactions. They're called funded Space Acts or unfunded Space Act agreements. That authority emanates obviously from Congress gave us that authority when we stood up NASA. And the point of that authority is that whatever we procure using that authority does not just directly benefit NASA, it benefits what we would consider the space economy or the aeronautics economy. That's what makes NASA different than many other federal agencies in the United States, is that we exist for the benefit of humanity. That's our tagline. But we also exist to stimulate the economy with respect to civil aviation and civil space. We are not regulators. That would be our Federal Aviation Administration, but we do work hand in hand with Federal Aviation Administration. But there is a 5th transformational area that's not on this slide, and that's what we call the innovation ecosystem. So everything in aviation that we're working it works off of the backbone of the innovation ecosystem. And that particular ecosystem is how we produce knowledge and ideas through, it might be research projects or announcements, partnering with with industry, and that's how we lead what ultimately to new transformation ideas by partnering. So we're going to give you some examples. Some of them have actually been talked about today. This first example is what we call the Boeing Sustainable Flight Demonstrator. So Boeing is our partner with that particular procurement. That is a partnership agreement where the government's contributing an amount of money and Boeing is contributing an amount of money with respect to how we're trying to accelerate the next generation of large commercial aircraft. The intent here, like many of the speakers talked about, is to use less energy and to use cleaner energy. We like to say greener, cleaner, and quieter. So I'll talk about quieter later on. But we are also working, and a number of the speakers over the last 2 days have talked about this, to contribute to the U.S. goal of a net zero greenhouse gas emission by 2050. And so a lot of these projects are the pathfinders for how we're going to get to that, limit the greenhouse gas emissions by 2050. All right. So this here is another program that we use when we call ultra-efficient airliners. This one is also a picture of a Boeing aircraft here, and we're talking about SAF. There's been a lot of discussion about the sustainable air fuel, but these are all the different things that are being tested, and that we call it like a test bed there. But we do have other partners that are in the Eco Demonstrator program, and those partners doing different things to make more ultra-efficient airliners are across the bottom there. So you can see some of those partners. And there are others. There are more than 80 industry partners that we work with. These are just some of the prime contracts that we have there. Okay, we'll talk about high-speed aircraft, and we talked about that from a perspective of we want to be quieter. So we're kind of going back to the future with respect to supersonic aircraft. And what we're looking to do here is we're looking to test. We had hoped that we would fly the X-59 this fall. We're a little bit behind schedule, but this is a program that we have partnered with Lockheed Martin Skunk Works. And we hope to transform what we call commercial flight into high-speed commercial flight. We're trying to address that unique barrier about enabling global access to high-speed flight. And our first barrier, obviously, is sonic boom. So as you all know, I think commercial aircraft are prohibited from flying at the supersonic speeds, largely due to international regulation and that disruption that occurs when you have a sonic boom. So our near-term focus is to demonstrate this particular aircraft that would be able to quietly fly over land, and then we are, in an interesting way, leveraging selected U.S. Communities to be able to give us feedback. We have volunteers that we're not obviously paying to provide their responses to what they hear and what they don't hear. We're leveraging in this particular program years of fundamental research that's been done in this area that talk about what actually creates that sonic boom and what we can do to mitigate that sonic boom. You might hear, other than the X-59, LBFD, which is Low Boom Flight Demonstrator. That's another name that we have for it. With respect to other things that we're doing in this area, we're also investigating the potential for even higher speed flight. Not this program, but there are a couple other studies that we're doing. And we're looking at the commercial viability of obtaining higher than Mach 2 flight. If we were able to get to higher than Mach 2, obviously that would be a record-setting endeavor. And so we're doing some paper studies on some of that now. The next area would be advanced air mobility. So this is a really fun slide. It's a bit of an eye slide, but if you look at it later on, these slides will be available online, you will see what we have is very congested airspace. And we want to try to work with, we have more than 80 industry partners on contract here as well, developing not just new vehicles, but how do we operate vehicles better and differently. We're looking at airspace design as well as these community integration solutions. So the intent with this particular program is to enable that sustainable advanced air mobility system that would then support U.S. economic growth. So if you saw the video, which we all watched the video, you'll see things like dropping medical supplies, things like air taxis, things that would benefit the public. We're going to go back to one of NASA's core missions is to benefit the public. And that could be in a rural environment or an urban environment in particular, where it's oftentimes hard to get to those environments to deliver, I'll say, goods, services, or needs to those communities. We also are looking at this as a means to develop and deal with a disaster response using some of the air taxis and on-demand passenger service, which is what really Uber in the sky is what I call it. But I'm looking forward to being able to participate in that one day. So there are three areas in AAM. So it's like three domains kind of that we're doing. That vehicle development and operations, which I talked about first. The second one is the airspace design and operations. And then the third is community integration. So those are the three areas that comprise all of these particular studies and feasibility things that we're doing there. Once again, this is a case where we are using unfunded and funded partnership agreements, not formal contracts. We are sharing facilities and we are sharing expertise. A lot of the time we have these partnership agreements. It allows us to be able to share our intellectual capital within NASA, with industry, free of charge. Most of the data you will find, in fact, I was speaking with someone at the gala, like 90 to 95% of anything that's generated at NASA will be publicly available. That's really good. You can think about that. Maybe isn't good too, but that's what we exist to do, is to do this research and make it available to anyone and all people. So then we also have shared data, but then the idea of that shared expertise to actually get, I'll say, the brain trust sharing, that does require a partnership agreement. Any data generated from any of our agreements or any of our contracts would be made available. It's publicly available, mostly online or through our technical community. But another thing that NASA has is a number of very unique facilities, like our wind tunnels and different things for computational things that don't exist, that require huge investment in infrastructure that a lot of the smaller companies don't have that infrastructure and facilities. And so oftentimes we enter into agreements for them to be able to use those facilities at cost. In most cases, we do not make profit on those things. All right. So when we talk advanced air mobility, I wanted just to quickly state that Oops, if I can go back. I don't know if I can go back. Okay, want to quickly state that just to underscore a couple of the things that I mentioned, we're talking rural and urban application. So that's in particular what NASA's looking at. We're talking cargo transport, we're talking passenger carrying, and we're talking aerial work. We are enabled in this particular area with electrification and automation. So we're doing a lot with, electric motors and that kind of thing and automation, not necessarily a person. But it does not include anything in the supersonic or hypersonic world, nor does it include any existing hub and spoke air service with large transport aircraft. So what we're trying to do is develop these technologies to safely enable AAM operations without overloading the current air traffic management system, and that's key. We work very carefully and closely with our FAA, which are our federal aviation regulators, to make sure we don't kind of screw with that system, because that system is very delicate, and we want to make sure that we work within the current confines of that particular system. But I will say through these collaborations, some international, some within the United States, small businesses as well as educational institutions and research centers to jointly research and validate concepts of operation and core technologies. So in this area, it's not as much things that are successful, but we also document those things that are not successful. When NASA looks at innovations, we want to make sure that people know where we've been and the things that we've tried, so they don't have to duplicate what we would call a successful failure. That's a term that NASA uses quite a bit. All right, let's go to where we're going next here. So where we go next is the next generation for future airspace and safety. We call it, we're in the era of next gen. So today, NASA partners with, I mentioned before, our regulators and industry to test software tools that can be used on flight decks and in control towers. We want to make these flight paths more efficient. We want to be able to save time on the ground at airports and reduce delays to travelers. And we've been doing quite a bit of tech transfer over the past 20 to 30 years. We're at a place of now we can integrate some of that technology transfer, and we're on the cusp of developing tools that will increase our options for safe, sustainable, and decision-making in aviation in an even more collaborative environment. So this new collaborative environment, we have coined the term infocentric NAS, or NAS. We're expecting this new collaborative environment to be in place by 2035, and we have a number of goals to help get us there. So as I mentioned, working with these regulators, we're building on efficiency gains, but we're also leveraging these digital capabilities that have been kind of housed and shelved and integrating all these things into new applications. So our ultimate objective is an airspace that's safe, adaptable, and it's scalable. So when we go out to, there's a lot of computer modeling that goes on. There's a lot of looking at, where's your high traffic, where's your congestion, where are air lanes that we could use to be more efficient that maybe will contribute more measurably to a sustainable environment in aviation. But after we do this idea of infocentric NAS, then we want to talk about Sky for All. So that's what's next after that. That's where we will leverage all of those infocentric NAS applications and successes and advancements, and then transition to a highly automated airspace. And NASA sees for the future, as many have discussed here, this automated airspace that will handle complex streams of traffic and scale to meet demands seamlessly, in some cases without even a human in the loop. So what's next for aviation in the 21st century? Let's see if I can, Is it not, oops, sorry guys. Okay, this is what's next for us. We believe, based on our forecasting, there are three primary drivers that are going to shape the global aviation industry. Our global aviation challenges are about scope and impact and demand. And we see scope, impact, and demand continuing to grow. Many said that earlier. We want to be cleaner, we want to be greener, we want to be quieter. We want our system, which is our second impact, to be sustainable and safe. And then we will transform, and we believe in the United States that we'll continue to transform our economy and the world economy as global neighbors through our society, using innovation, leveraging each other's convergent technologies inside and outside of the aviation sector. I believe the Bombardier leader did talk a little bit about that, the chief procurement officer, about this idea that high tech is converging with aviation. We are starting to see a lot of our students that wanted to work in aerospace coming back to look at aeronautics, and people are excited about the possibilities of the convergence of some of these different technologies. So NASA does play a critical role in leading transformation of global aviation with many of the efforts that you and this audience have partnered with us on. We appreciate that partnership. We expect to continue with that partnership, and we want to focus on some strategic thrusts. So I also included John Montgomery, who's my technical partner, because like I mentioned before, I'm the Chief Procurement Officer on all of these projects. He sponsors all of these projects. We will have a QR code for anybody that's interested in upcoming NASA procurement. I mentioned before, like 99% of our stuff is unclassified, it's open public, and we have a lot of international relationships with partners. We are pushing that from the administrator on down. If you look at our Artemis Accords, at least in the space exploration area, we have more than 23 global partners or countries that partner with us in that area. We want to do the same in aviation. And then we do have a program specialist that specializes in international and interagency operations, and Nathan's name is up here as well. So I think I don't know if I'm over, probably I'm getting the hook, but I'm happy to answer questions afterwards if anybody does have questions.
Mrs. Smith Jackson, thank you so much for presenting